on Markov chain Monte Carlo, specifically the Metropolis Hastings algorithm. So Markov chain Monte Carlo are a class of algorithms for sampling from a probability distribution or finding the expected value of such a distribution, where doing so, analytically may be very difficult or just intractable. And the idea behind this, you given a starting initial point, you randomly pick a nearby point and calculate the probability of that point. If the probability is found to be higher, then you move to that point. Otherwise, you stay at the current point, or still move to that point with a given probability. And it's found that if you repeat this process long enough, under some assumptions, that it hits every single point within the sample space with the same frequency distribution approximates from the probability distribution that we're drawing our samples from. And to understand this better, we have the idea of Markov chains. So Markov chains are a sequence of states whereby the probability of moving to the next state depends solely and entirely on the present state and not on the previous states before that. So from the diagram we have in the slide here, we have an arrow from state 1 to state 2 of where the arrow represents the probability of moving from state 1 to state 2, which is 0.34. And from state 2 to state 3, 0.65, and does not depend on state 1. So the probability of moving from state 2 to state 3 has nothing to do with state 1 at all. And of course, we have a probability of state 1, staying on itself, which here is 0.058. And a simple example, is performing on a normal distribution where you have a random walk on a normal distribution, whereby the number of iterations taken as 250,000 is found to have, sort of the same shape as a normal distribution, with the mean centered around 0 roughly, and with extreme ends, with very small samples at extreme ends, and many more samples concentrated in the middle. And it's found that if you take higher results for n, the results generally get better. So the implementation is as follows. You initialize a given x, you initialize the given state, sorry, and then you draw a proposed distribution depending on the current states. So here we have the idea of a Markov chain where the proposed state is drawn from a current state by the proposal distribution function. And we either accept or reject the state depending on whether the proposal distribution is higher than the current distribution given by this sort of fraction or ratio here. And this Q here just really represents the proposal the probability of the current states given the proposed states and the probability of the proposed states given the current states. And in the case of the Metropolis algorithm, and this is the Metropolis Hastings algorithm now, but in the case of the Metropolis algorithm, these two cancel out as they are both symmetric. So we only focus on the probability of the proposed states and the probability of the current states. And we accept the probability of the proposed states, if it's the case whereby u, which is a random number drawn between 0 and 1, if it's the case whereby u is less than, the minimum of 1 and this state here, and so we accept the proposed state then, otherwise we still in the current states. And it's important to note that even if it's the case whereby the proposed state is less, the probability of the proposed state is less than the current states, depending on this value of u, we still have a chance of, still moving to the proposed states. Otherwise, if both conditions don't work out, then we just remain where we are. So we initialize the next state to the current state, which is the same state. So the importance of this algorithm is, it was named the top 10 algorithms of the 20th century due to its influence on science and engineering by the IEE Journal for Computer and Engineering. And applications of this, really vary from decrypting ciphertext to finding approximate applications to the NAPSA problem, to computational statistics, and also to even predicting future conditions on railroad bridges. So given all this that we've talked about, we can see clearly why the Metropolis Hastings algorithm, has really influenced science and engineering, and it's really changed the world.